Today we are going to talk about the chain rule. The chain rule is one of the tougher tougher concepts in differentiation. So I ask you to put in extra effort and extra time for this section. The chain rule is very important, and you absolutely need to master the chain rule. So having said that, first let's see what is the chain rule. What the chain rule says is that if you have a function that's made out of two different functions. Let's look at, to say that, we are on page 288, where we state the chain rule. Let's say you have a function that's a composite of two functions. How do you take the derivative of that? Now, as an example, let's look at what the book says. Say h of x, okay? Let's go back to 287. Where the book gives you an example of some function h of x, which is composed of two things. It equals the sine of x to the power 3. Now, so far we know how to take the derivative of the sine, it's just the cosine, and we know how to do the derivative of x to the power 3. But what happens when you have something like that going on? Then so far we don't know how to handle this. Okay, how would you do this? So there is a simple, well, I don't know about simple, but straightforward rule of how to do this. And here's the rule. Now flip to the next page. The rule says that if you have a function, okay, so h of x equals to a composite function. This is f of g of x, where in this case f of x equal the sine of x, such that f of x is equal to the sine of x, and g of x equals to x cubed. See? And h of x is like f of g of x, like this. Right? The composite function, recognizing the composite function is a crucial part of learning how to use the chain rule. If you feel rusty about this concept, please look back in your algebra. I don't know where they taught this, and refresh yourself about what is a composite function and how to recognize one. So anyway, composite function basically means you got one function stuck in another function. And how are we going to take the derivative of that? The derivative of the composite function actually goes pretty smoothly. Okay, it ends up being something like this. To do the derivative of h, the rule, which is called the chain rule, says this. We will take the derivative of h is you have to take the derivative of f with g still in it. And then you will take the derivative of g and multiply it, g prime. And that is the chain rule. That's all of it. And that looks pretty decent. It's short and sweet, right? But sometimes the difficulty in the chain rule lies in sometimes people can't recognize what's the f and what's the g. And yeah, so that's why it's important for you to remember how does the composite function work, and be able to recognize what's inside what. Now, having said that, next thing we're going to do is prove the chain rule. The proof is a few pages later on page 294. So let's flip there and prove the chain rule. Come on. We get to 294 where the proof is. Now, to prove the chain rule, first we go by principle, right? But first, we have to have certain conditions. That is, we still go by these nomenclature, but there's one small requirement. We have to require that g of x cannot be equal to g of a. In a small neighborhood where as long as x is not equal to a, g of x cannot be equal to g of a. Why is that? Because if it equals, then we're going to subtract this by this, and the denominator is going to be 0, and then we're stuck with the impossibility of dividing by 0. So this is a requirement that g of x will never be g of a. All right. Now, having said that, let's look at the proof. First, we go by the principle. Okay, the definition of h prime, the derivative of a the derivative of h at the point A is by definition, let's pull out this definition. X approach A. Now notice we're not using that h definition, we're just using the other one, where x approach A and then the difference. Limit, anyway, so the limit h is defined as f of g of x minus f of g of a divided by x minus a. That is the definition of h prime, the derivative of h at a. Well, so far so good, right? That is what it is. But that looks complicated. So we're going to simplify it by some trick, a similar trick that we've been pulling so far. We're going to multiply everything by the same thing. So here's what we're going to do. H prime of A equals to this exact thing. I'm going to write it down again. It takes time to write it down. Is equal to this thing. Keep copying. F of g of x minus f of g of a. All right. And then x minus a. So far I've copied that exactly same thing down. But I'm going to multiply it by some fraction that's identical. Okay, this fraction is no accident. We're going to choose, purposefully multiply it by this. G is a trick in the proof. Gx minus g of a divided by g of x minus g of a. So we are going to multiply by a fraction that's identical top and bottom, which means we're multiplying by 1. And so the equation still holds. You can always multiply by 1 and not change yourself in any equation. Okay, why are we doing this? There's a reason for that. And next, we're going to rearrange these terms. Now, the magic happens in doing something very simple. So far, we're doing something very simple. We will rearrange. We'll put the x minus a here and put the gx minus ga there. That's all we're going to do. So, and which means there is a lot of writing involved. So let's write. Patiently write this stuff. F of g of a divided by, we're going to move this over, g of x minus g of a times, and we'll move this thing onto the other fraction, g of x minus g of a x minus a. Now, after all this writing, well, I have only moved the denominator over. Okay, I haven't done anything profound yet. But this is a very neat trick, as you can see. So far we have, you notice that this, it looks similar to this, right? The bottom is looks similar to the top. That's why we're doing this. See, x minus a, g of x minus g of a. This looks somewhat similar. We're lining things up, and for a very specific reason. Next, now here's where the magic happens. Check out the magic. Now, next line says that we're stating a fact. We will not write down the equation yet. Here's a fact. Now, by definition of g, first, this equation is the same as taking the limit of each item. Okay, when things are being multiplied in a limit, you can take the limit of each one. So what is the limit? Let's first focus on the limit of this thing. What is the limit of, let's see, x approach a of just this one? Let's consider this one first. The limit as g of x minus g of a divided by x approach a. What is the limit of that? The limit of that, this by definition, equals the g prime of x. That is prime. Okay, g prime of x. That is that's one way to say g prime of x, and we know that g prime of x exists and all those things. So let's not worry. Let's just say it exists. If it exists, then this is the value, right? So far so good. We know what this is. That's the okay. But what is that? And that is a lot of symbols, and we need to figure out what this thing is right here. Now, in the meantime, we're going to pull a somewhat stiff trick, okay? And that is, which is this. Now look down. We're going to do something that we have not done before this, but it's important that you study this very carefully and understand it, or at least try to. So what we're going to do is do a substitution within the limit, which I don't remember doing this before today in this class, but we're going to do it anyway. That is, we're going to do an interesting substitution. We're going to let something called y equal to g of x. And then we're going to let b equal to g of a. Now remember that g of x is a variable, right? So we can call it y, whereas g of a is some constant. Therefore, we'll call it by another constant, which is b. And then we're going to substitute this part into this. So, and rewriting just this part, then the limit as x approach a, right now I'm just going to copy it down. Okay, just this part, which I will copy it here, f of g of x minus f of g of a, divided by g of x minus g of a. So far I've copied that down correctly, I hope, which is, and I'm going to do this substitution. Again, we've never done this substituting stuff within limit before, but we're going to do that now. So if we were to do the substitution, g of x is y, so that becomes of f of y, all right, on this side, f of y minus f of b divided by, where's my limit? I need the limit. Equals to limit. All right, there's my limit. Minus y minus b. And here's the tricky part. As y approach b, that is, we believe that as if g of x equals, as x approach a, then y will approach b. And the justification for that is in this sentence, because the limit as x approach a of g of x equals to g of a. And in other words, this means as x approach a, g of x approach b. B is g of a. Now this is very important. Now how do we know this? This is because g of x is differentiable and therefore continuous. we have a theorem that says if something's differentiable, well, it's surely continuous. So that established this point, and therefore this is true. And that's why this equation holds. Now at this point, if this seems confusing to you, please read it again, like 50 times or something, until you get it. From about this point to this point, please keep reading it until you understand this. So once you get to this point, then we have arrived at our destination. Why? Because this particular limit is by definition the same as okay, I will copy that down again. The limit as f of y minus f of b divided by y minus b as y approach b is by definition f prime of b. And that's why we have the original requirement here that g of x cannot be equal to g of a in this neighborhood. Otherwise, you are dividing by 0. So this cannot be 0 in the small neighborhood, in the delta neighborhood. As long as it's not 0, then this particular relationship is sound and established. And what is f prime of b? B is what's b again? B is g of a. And therefore, our original statement, which is right here, h prime of a, what we were doing this whole time, is h prime of a equals to this thing, okay, which we established as f prime g of a. Which is this part multiplied by this part, which is, as we established here, what is this? Where did it go? Well, anyway, this part is g prime of a, is right here. And that is the chain rule. Now, the chain rule might seem confusing. That's because it is somewhat involved, especially there is a substitution within the limits, which you may not be accustomed to. But it makes sense if you stare at it for, I don't know, and again and again. The way you should, if it doesn't make sense to you at first, please read this part. When the book gets to here, and then just continue reading it again and again. You get to the point where it does make sense, and then when you hit something that doesn't make sense or kind of confusing, then go back to where it does make sense and read it again. And do that for, I don't know, half an hour or an hour or something until your brain is forced to understand it. Okay? Force your brain to understand this thing. However, after an hour or so, whether you understand or not, let's move on. Is that understanding the proof of the chain rule is not required to use the chain rule. It's like understanding how the calculator works is not required for using the calculator. So that, which is why your book decided to put the proof at the end of the section. But we are going to do it the first thing because, it's to prove the chain rule, right? We need to get through it. So, but now that we got through it, let's look at some examples. But first, please spend some time understanding this. Beat your brain into understanding it. Put in some time. So let's look at some example. Now let's go back to page 288, where we look at the chain rule again. What is the chain rule? To summarize, the short form of the chain rule is if you have a function where h is a composite of f and g, then the chain rule states that h prime of x is equal to f prime of g times g prime. That's the short form of remembering the chain rule. Remember, it's f, did I say prime? Yeah, f prime of g times g prime. Now don't forget that it has to be f prime of g. It's not f prime of x. And we'll demonstrate that clearly in a moment. So let's look at the next page. There's an example somewhere. Which, well, first let's do the first book example on a page before, where should we do that? Sure. Where it says h of x. This is on page 287, the previous page, where it says h of x equal the sine of x to the power 3. And then the book went through the proof of that the hard way. But we are going to apply the chain rule and do it the quick, simple way. The chain rule says h prime of x equals to, first you have to identify what's f and what's g. Here we will identify f as sine. F of x is considered sine of x. Okay, and then g of x is x to the power 3. Therefore, h prime of x equals f prime. Okay, what's f prime? Sine of x is the derivative of sine is cosine. Cosine of g. What's g? You got to stick g in this thing. Okay, and then we'll take the derivative of g. What's the derivative of g? The derivative of g is 3x squared. Okay, by the power rule. And in the meantime, you got to stick g in here. What's g? G is x, happen to be x cubed, and that is your answer to h prime. So you just have to identify what's the outside function and what's the inside, and then write it out in one line. See, the chain rule is very neat that way. You usually don't have to work that hard. You just have to identify which function is f and which function is g. Next, let's look at the next example, which is example 3.48. This is on page 289. Which says that, let's do this example. It says h of x equals to some function 1 over 3x squared plus 1, and then squared. So how do you identify which one's f and which one's g? Let's just say that f equals to, there's a blob of stuff here, and we'll just call that the f. Okay, so we'll say that f of x equals to 1 over x squared, where x represent all the stuff in here, whereas g of x is what's in it. G of x equal to 3x squared plus 1. And then together, they will become h of x. Now, having identified that, then h prime of x equal to the derivative of 1 over x squared by the power rule. This is minus 2, okay? And then 1 over this thing, whatever is inside, to the power 3. That's whatever is inside. But that you are looking at it as one glob. Okay, this is your entire variable, f of x. So you do the derivative of f. And yeah, keep whatever's in there. And then you take the derivative of g of x. That would be 3 times 2 is 6. X. That's it. That's the derivative of g of x. 3 times 2 is 6. And then x to 1 power less. And then you write down whatever's in here, which is 3x squared plus 1. And that's your answer, by the way. That's it. And if you clean it up a little bit, then you get minus 2 times 6 is 12, and 3x squared plus 1 to the power 3, and there's an x on top, and that's your answer. So please do this example yourself at home, as you should do all the examples, right? And having said that, let's do the next example. Example 3.49, which says that you got something. Actually, we just did example 3.49. Okay, sine cubed, yeah, is No, it's not. It's different from this one. Never mind. So let's do example 3.49, which is slightly different. H of x equal to sine to the power 3x. Now that is, remember, that's different from that. How is it different? This is the same as the sines being multiplied 3 times. Whereas this one, the x is being multiplied 3 times. Remember the notation. Okay, that means that. Why does it mean that? It's tradition. But we don't care what it means. We will just do this. And so what is f and g in this situation? We'll call f equals to, so we'll call f of, in this situation, f of x is just take whatever's in there, okay, raised to the power 3, all right? And then whereas g of x is just sine of x. And together, you will, h of x is the combination of these two and becomes that. Now, having said that, let me stand over here. And so having said that, then you have, let's write down, apply the power rule. Apply the chain rule. You have, the chain rule says f prime of g. So first, let's do the derivative of this thing, which is 3 stuff squared, okay? That is, remember the power rule, write down that number, and then whatever's inside gets 1 power less. And then times the derivative of g is sine, that the derivative of sine is cosine. And then once you've done that, you need to write down what's in here. What's in here is g of x. G of x is sine of x, so you write that down, sine of x. And that's your answer. Now, what does the book say? Yes. And then you can choose to rewrite this thing the normal way. That is, you put the square next to the sine. Okay, by tradition, sine squared, this one is written like this. So sine squared x means sine x squared. And that's your answer. See, it's quick and smooth. All right, now for homework for today, please do on page the homework section. The reason I have you do homework section now is because the chain rule is really many students find the chain rule quite a bit challenging. So, and to get used to the chain rule, what you do is just you keep working on it until you feel comfortable with it. So that's why I'm dividing the chain rule section into 2 parts, and I would like you to basically you do twice as much homework as the normal section, which the chain rule totally deserves. All right, and that will make you comfortable with the chain rule, and the rest of the calculus will go much smoother. So please do your homework number 221, 23, 27, 29, 31, and 33, which I've also written down at the bottom of this video. And also included with your homework is the next example, example 3.50, which is a straightforward problem of finding the tangent line again, something that you've done several times by now. And it's fairly straightforward, so please do that as part of the homework.